Let's do this. What's the difference between a thread and a process?
Uh, Hey, sorry, I was reading the stream to line up.
Yeah.
I'm a new grad software developer. I'm currently working in FAANG.
Let me ask you a question about like what language do you write at work?
I do Rust.
Rust. Okay. What did you do in school? Like Java, Python, C++?
Yeah, school touched a little bit of everything,
Okay.
from from object-oriented programming with Java, then then a little bit of JavaScript as well, and some C++ for algorithms. But yeah, I kind of don't specialize in one language, which is kind of my weakness. And I was hoping to, maybe look into C++ to be like my strong suit.
Yeah, if you want to go into quant, unless you want to go into like crypto stuff, you're gonna need to do C++. Did you do any C in school?
Yeah, yeah.
Okay. Um, what version of Rust do you use?
I cannot answer that. Um, yeah, most of the time, I feel like at work, I'm just fixing things. Um, some of the concepts that you mentioned in the videos never gets applied pretty much. They're all abstracted away. That's why um,
Okay.
I'm not sure. I don't want to go on a tangent. Sorry.
What's your favorite thing about Rust or feature? Favorite feature, not favorite thing.
Uh, I like the fact that once you've written it, it's safe. Obviously, if you don't touch unsafe code, everything's safe because of the compiler checks making the code like memory safe. I like that. That slows down development speed, but it makes you're confident that there's no memory leaks or some sort of no pointer dereferencing.
Okay. What do you not like about Rust?
Um, Sometimes they're just constraints because of the borrow checker. Sometimes there are things that are really obvious, um, especially in the multi-threaded ends. Sometimes things are pretty obvious, and uh, you just can't seem to make it work. Uh, yeah, it's not the best answer.
Okay.
I can't say I'm like familiar with the language either because I'm actually pretty new on the job as well.
Okay. You mentioned multithreading.
Yep.
What is that?
So you can have multiple processes. Sorry. Let me put this better. So it's the idea of a program um, running, having their own stacks. Oh, sorry. Each thread has their own stack, so that the process can be ran faster and concurrently, or it could be concurrently if you have multiple CPU cores, and if you don't have multiple CPU cores, the the OS can schedule the different tasks of the thread.
Okay. What is a thread?
A thread is, I'll say, is like a branch of a process.
When I think of a branch, I think of like an if instruction. So what do you mean by branch? Let me go. Let's do this. What's the difference between a thread and a process?
Uh, a process has multiple memories. Sorry. It's pretty late where I am at, but I wasn't expecting to get grilled here. But
There's no grilling. It's just a
yeah,
question. I'm not trying to like. There's no got
yeah,
yous.
yeah, yeah, yeah. I need to study that for sure. I don't have a definitive answer, but from what I know, is a process can have multiple threads.
Okay. The main difference is that okay. Let's ask this. Which ones share memory? Threads or
Uh,
processes?
threads.
And how do you prevent them? What are some problems that may arise from shared memory?
Um, let's say the program expects something to not be mutated, but then the other process mutated it, then
The other
the
process
process
or the other
doesn't know.
thread?
Like I'm assuming you're saying like what's what your what's the issue with like two process sharing the memory? Is that the question?
What's the problem if what are some problems that may arise if two threads share memory?
Oh, concurrent like sorry, what's that called? Race conditions. Yeah, race
Okay.
conditions. So one thread can access data first, and then you take the data, and the other thread expects something to be in a certain state, but it's already altered by a different thread. So that's why, yeah. So that's why you get like wrong values. So you have multiple threads, like just printing, even just printing the values. Like let's say you have a counter 1 to 10, and you have multiple
Yeah, no,
threads.
that's
Print it
fine.
out. Yeah.
That's fine. You don't need to give an example
Yeah.
there.
Yeah.
Sorry, let me put a pause there. Guys in chat, can you see my screen right now? I'm playing a game. If you can't see it, please put, if you can see it, put 1. If you can't see it, put 2. Let me ask you this. What's the difference between a hardware thread and a software thread?
Ooh. I'm not sure. I'll just say I don't know the answer to it. But my attempt would be like I've heard something about green threads. Um, I'll say like a software. Yeah, I don't know. But would you
Okay.
should I give it an attempt?
No, if you don't know, that's fine.
Yeah.
Because then
Yeah.
you might bury yourself. Okay, so do you know what happens? Do you know what the term is if you spawn more software threads than hardware threads?
I don't know.
Okay, it's called oversubscribing. Now, is anything ever really? Let's just say you have a single core CPU that has one thread, one hardware thread.
Yeah.
But in your Rust program, you spawn 10 threads, for example.
Yeah.
So you have 10 software threads, but you have one hardware thread.
Yeah.
What happens in that case? What does each thread need to do in order to run? Like, what? Give me. This is a broad question. I want to see where you take it.
Yeah. So my understanding is the OS manages the resources, right? So the
Right.
OS manages which thread gets processed,
Right.
and we could go into scheduling algorithms. So depending on the implementation of the scheduling algorithms,
Sure.
but basically when I read the book a long time ago. So you have like the round robin, you have you have like the priority. I don't want to bury myself, but yeah, you have different scheduling algorithms that the OS cares about, and then basically when certain programs or threads are doing things that are very slow, let's say IO intensive, like reading from network or reading from file, or reading from disk, sorry, then like the OS will switch the thread, context switch, bringing all the variables and things like that
Sure.
into the register, and then it switched to a different thread.
Okay.
So yeah,
Let's pause there first. What is a context switch?
yeah. So a program has different like so when a program is running, it has different variables. It has yeah, sure, like different variables, and then um, but then you only have like so few registers. You can't like the register itself can't store the values for um, many different programs. So in order to switch context, you will have to push those values from the registers on into memory, and then fetch the the other program, like fetch the other um, thread parameters into the registers so that the CPU can continue running those things.
Okay. Um, what happens if there is no like I/O bound work? So let's say you have process A. Let's say like back to your Rust example. You have thread A and thread B. Thread A is currently monopolizing the CPU, so it's being run on CPU 1. And you have thread B that's waiting to be scheduled to do work. Okay? You following me so far?
Yeah.
Now let's say thread A never has an I/O bound task, so it just keeps grinding. What part of the operating system or what component will allow thread B to be scheduled despite the fact that
Yeah.
thread A never gave up its time slice? It never relinquished itself due to I/O bound work being present.
Yeah, that depends on the the scheduling algorithm. So if it
No,
was an algorithm that,
this goes beyond the scheduling algorithm. So I get it that
oh
you know what
really?
a
Yeah.
scheduling algorithm is, and then like the CPU will allocate a time slice to each thread to run on whatever process. But let's just say that there was, let's just say for example, the scheduling algorithm was gamed in a way that a single thread can continuously be running and it has no I/O. What would the operating
Yeah.
system do, or what mechanism would the operating system have to tell thread A, hey buddy, stop. You're gonna need to like relinquish your control now.
I was gonna say it has like a timer, but I still think that's a scheduling algorithm, so I don't think we're talking the same thing. So to that, I don't know.
You're kind of close, like an interrupt timer. So it'll issue like an interrupt to the actual process itself and tell it, hey, by the way, like you're done. Let's talk about scheduling algorithms. So scheduling algorithms try to make trade-offs between two things, two metrics. Do you know what those metrics are?
Time and memory.
There's two forms of time.
Um, so like clock cycles.
No, there's response time and turnaround time.
Oh yeah, that makes
This,
sense.
right, because you don't want to have a program scheduled where effectively the CPU doesn't get to it until like another hour. Then it'll just be freezing. So you want the CPU to respond to that program's existence or that thread's existence quickly, but you also want it to complete the job that the thread has tasked for it quickly. Um, okay. What did you ever take any operating systems classes in school?
I did, but my course was kind of broken into a computer architecture, no less. So we didn't
Okay.
go in
I mean,
depth
you said
into
you also
it.
read the book, the Operating Systems 3Z Pieces book. Um,
I'm only on the first chapter, to be honest. Like
okay.
the scheduling part. I'm not
Let's continue on
but
threads
I'm
though.
up for the challenge.
Okay, let's continue on
Yep.
threads though, because you also took it in school. So, in terms of threads, what sort of constructs are there to prevent things like race conditions that you previously mentioned?
Uh, so you have locks. You have mutexes. Um,
How does
and
so
yeah,
how does a mutex work?
um, mutex. I believe it's like a counter of how many things are using the how many things are using that particular region of memory or to that particular object.
And that's more of a semaphore than a
Oh
mutex.
yeah, I think I was talking about semaphore. By
Yeah.
mutex, did you mean like a mutex lock? So it's just a lock, right?
Yeah. A lock takes a
Um,
mutex. It acquires the mutex.
yeah, that part I'm actually not too sure. But like like the term mutex and locks. But my understanding of locks is when a particular thread acquires a lock, it's like one global lock.
We
Then
get it.
it
It,
can have
ex- it
access to the
excludes it
memory.
excludes other threads from being able to
Yeah.
take that lock. Have you heard of the difference between like a spin lock and a sleep lock?
No, I have not.
Okay. So you haven't heard of the term busy wait?
No, I haven't.
Okay. So they're just so I guess the audience knows as well. There's two types of mutexes in general, and most of them are actually implemented as a combination of these two types. So there's a lock that is a busy wait lock, which essentially means that the thread that's waiting to be to run that critical section of code is spinning, so it's remaining hot. And then there's another type of lock where the thread that's waiting is put to sleep, and then it's notified when the thread that accessed the critical section of code relinquishes control of it. And so, see, understanding how those two things are implemented and what the lock that you're using actually does under the hood, because most of them do both. Um, they try to acquire the lock, and after a period of time, and after a given number of attempts, they yield and they go to bed essentially, or they let the scheduler schedule another thread to run. So, understanding the implications of those, like which locks you're using, what they're doing, that's part of the world of quant trading as well. Let's kind of shift here because I feel like we've gotten to the border of your knowledge in terms of threading. What's your experience like networking and stuff like that?
Very minimal. But I can tell you what TCP, what UDP is, and that kind of
Okay,
like
so
I can tell you a high level of it. Yeah,
okay, so what is TCP?
TCP is like a reliable transfer protocol.
What does it
It's
stand for? What does it stand for?
oh, transfer connection protocol. If I remember correctly.
No, transmission control protocol.
Oh, yeah. Completely.
So what are a couple of characteristics of TCP?
Yeah, it's reliable. Yes, it's connection. It's connection based. So, um, yeah, it's reliable and connection based. Yeah, I'll say that's a defining feature.
What do you mean by reliable?
That you guarantee that the packets arrive in order, and that the like you won't be missing any packets.
And what mechanism does TCP use to ensure that? How does it do that?
I don't. I'm not sure other than like a checksum, to be honest.
So does checksum have anything to do with sequencing, or does it have to do with data integrity?
In data integrity for sure. Yeah.
So what does it have to do with sequencing and in order delivery?
I would. This I'm not sure, but I would assume that the protocol, like at the beginning, it will say like, okay, there's going to be 10 packets, and there will be a sequencing for each packet that says okay what the sequence number is.
Okay.
So if the receiver, after it knows that it's going to receive 10, and then it gets 1, 2, 3, 4, 5, and then it's missing 6, then it would request again, hey, I'm missing 6.
How does the receiver tell the sender how many bytes that the sender sent it acknowledges?
I'm not sure.
Okay. There's something called just like simply a. They both maintain a bidirectional stream of sequence numbers. One of them just sends back a packet that acts and says, I've acknowledged this many bytes that you've sent me. So
right.
it's
Okay.
really simple. Okay. How do you establish a TCP connection?
There's a 3-way handshake.
Okay. What's sent in the
believe-
first handshake?
And acknowledge.
No. What flag is sent?
I don't know.
Okay.
I'm not sure. I was assuming that it was like acknowledging, like it was, like maybe it's like the caller IP address perhaps. I'm just
No. So there's a couple of flags in TCP/IP, and the one that's sent first is SYN. SYN. Do you have experience
Right.
working with Wireshark?
No.
Okay. What's UDP?
UDP, I believe it's user datagram protocol.
Okay. And if we were to do a video chat, not a YouTube live stream, just a simple video chat, do you think that would be UDP or TCP?
I'll still say it's UDP.
Why?
So I think video needs to be, even though it's not like a stream, like video chat is still like a real-time application. So you would want to, you would want to prioritize like the speed over like reliability. So you don't want, like I want to be able to hear and see what you're doing like right now, versus like whether or not like in a TCP where it guarantees what gets sent, but like it might be too late by the time like the retransmission happens. Whereas UDP is instant. Like I only care about what's happening right now.
Okay, I'll accept that answer. Okay. I'm assuming you're familiar with data structures.
Yeah.
Let's just talk like high level. What's an array?
Contiguous region memory.
I mean, that's how items are stored in it. Okay, fine. I'll take that though. Because there might be other data structures that store things contiguously. That doesn't make them an array.
Right. It's stored on the stack. Like you kind of have to predefine like the size of the array.
Okay.
In compile time.
So you said it's stored on the stack. which is right. What's the difference between the stack and the heap?
So first of all, there are two different regions, and then
Regions in where?
stack is regions of RAM
Of RAM?
for a program.
For a program,
Of,
okay.
of memory, memory of the program, yeah.
Okay.
And then stack runs faster just because everything is pre-compiled, and then the program can just use the stack pointer to find an object because it knows exactly where it is.
What do you mean it knows exactly where it is? Can you just be a bit more specific?
So let's say you have during compile time, everything is laid out in memory. Let's say you have two variables, like two ints, then the stack pointer would know that if you move, let's say one byte down, then it would be the memory address of the next int.
Okay. Okay, that makes sense. Yeah.
Whereas in a heap, it's a pointer. Like for things to be stored in a heap, it's like referenced by a pointer, and you have to dereference the pointer before you can get the object.
Okay. How many memory accesses is dereferencing a pointer?
Ooh, that's a good question. Dereferencing a pointer. So you have to get the variable from the stack.
Right.
That's one, and then that's already an address. So
Yeah.
2.
Yeah. Cool. Okay, I want to get to the next caller though, but do you have any questions for me?
Yeah. So would you say that quant work-life balance is really bad? I know in your videos you mentioned you did your 9 to 5, but I've heard way too many bad things about it to a point where I'm like kind of hesitant.
It depends on the firm, really. It depends how sweaty they are. Some firms are very elitist and a lot more sweaty. They'll pay you more, but it's really a trade-off between like where you see yourself and how you want to live your life. If you want to be a cracked-out sweaty dude that just codes all day, maybe like 8 to 6 or something, that's possible.
Yeah.
But there's also firms that are more chill.
Okay. Yeah. That's all I have.
Okay.
You know,
If you
I always said it. Yeah.
If you don't mind me asking, like, which FAANG are you in?
I'd rather.
You'd rather not? Okay, that's fine. That's fine.
Yeah.
There might be some people interested in like what the interview process was like. Is there anything that stands out in terms of what the interview process is like at a FAANG? Like maybe high level, tell me like what the rounds were like. Was it like an OA and then like an HR screen? What was the rounds like at your FAANG?
Yeah, I was in the intern pipeline. So
okay.
The intern interview was simply a recode interview, and then I do believe that the culture fit, it's more important in a FAANG or intern role plus in the FAANG company.
Okay, but maybe just lay it out high level. Yeah. Like first round was this, second round was this.
Yeah, it was one round.
One round for your FAANG intern?
Yep.
So it was just coding with a person?
Yep.
Okay, and then you got the like yes or no?
Yeah.
Okay. All right, thanks for joining.
Yeah, appreciate everything you do. Thank you.
Yeah.